So it's 10 o'clock Central European Time. Welcome to another webinar from Radiocrafts. My name is Peder Martin Evjen. I'm the Managing Director of Radiocrafts and will be your host today. So in this webinar, we will talk about the Wize ecosystem. And we are doing this webinar in association with the Wize Alliance. Okay, I'm also very pleased that we will be joined by two other Wize Alliance members today from Suez Smart Solutions and Enless Wireless, who will also give their presentations. So welcome to Mateu Crespi. He's the International Director in Smart Metering Sector at Suez Smart Solutions. And to Bruno Petit, he's the CEO of Enless Wireless. So Mateu will talk about Wize network access and local deployments. And Bruno will let us know more about end products for Wize targeting different applications, including building automation and smart metering. But before that, I will kick it off with an introduction of the Wize Alliance. Also look into some of the benefits of this technology and give you an overview of the radio module solutions for Wize. Just a few words about the housekeeping. So the webinar today is scheduled for some 45 minutes, with also time for some Q&A for 10 to 15 minutes. So please post your questions in the chat window during the talks, and then we will do our best to give you an answer in the Q&A session. And as always, this webinar will be recorded and it will be available from our website later on, so that you can watch it again if you like, or you can see it if you happen to miss it today. Okay, so about the Wize Alliance, I will give you a brief background. So it was founded by GRDF, that's the gas distributor in France, and Suez Smart Solutions, who is working on water metering, and Sacemcom, a telecom company. So all French companies. But today we are more than 40 members from 8 different countries. And it is the Wize Alliance that specify the Wize Protocol. And the Wize Protocol is actually based on the implementations and the experience from smart water and smart gas meter radio networks originally deployed in France. So this goes back to 2010, 2011, when GRDF did some evaluation of different radio technologies to be used for their gas meters. So they compared like 4 technologies, 169 megahertz, and then 433 megahertz and 868 megahertz, and some combinations of these. So these are all license-free bands in Europe. So briefly to show you the results of these pilot tests. So first of all, it was approximately between 4,000 and 5,000 meters installed. And yeah, you can see the figures on the slide here with the number of meters and also number of repeaters and gateways. So depending on the technology, some of them were using repeaters, like the 868 and the 433 megahertz, had some 900 repeater devices. And the number of gateways was also a bit different from the technologies. We see that 169 megahertz had 7 gateways, no repeaters, which means they have direct contact with the meters. Then we can see some of the results. So the purpose of this test was to see how good coverage you could get and if you could actually get meter readings daily from all the meters. So we can see here on the very top, on the upper left, the green line shows that for 169 megahertz, we always got almost got 100% daily readings. For the other technologies, 868 and 433, it's between some 80 and 90%, and at sometimes even much less than that. So the conclusions from these tests were pretty clear, that in order to get the very best coverage and at least daily readings, you should use a low frequency, narrowband radio technology with very good penetration. Remember, these were done with gas meters, which are typically installed indoors, in basements, or even down in pits. So this was the background why 169 megahertz was chosen as a very good frequency for meter reading. Okay, so based on this experience, the Wize protocol was specified. It's a low power wide area network protocol operating at 169 megahertz. And is really optimized for smart metering, for smart city, and for industrial IoT applications. So this means gas and water meters, but also supervision of the distribution networks and the grid. It can be used to monitor the infrastructure in a city, such like garbage bins and stuff like that. Could also be environmental sensors for air quality, and this could be both outdoors or indoors. Also building automation applications and any type of industrial sensors, such as process plant sensors. So what does the Wize protocol offer us? Well, it gives very robust communication and wide area coverage using this VHF band. It means secure transfer of data in terms of privacy, data integrity, and authentication by using encryption and authentication technologies. It's also a low power solution. And that is mandatory for applications like gas and water meters. When you have installed such a meter, you would like a lifetime for more than 15 years. And actually, you wouldn't even replace the battery, because normally the whole meter is like potted, and the battery should last the lifetime of the meter itself. So Wize is a solution based on the wireless Ambus standard. It's the mode N of the Ambus standard. That is actually the basis for Wize. Wize also offers firmware download over the air as an integral part of the protocol. And this is, of course, also important when you are deploying a network and devices that should last for 15 years. It's supposed to be some upgrade during that time. And that is then possible with the Wize protocol. So in summary, the benefits are very large coverage, it's a secure network with low power, and it's future-proof. Some more of the technical details. It's based on the wireless Ambus mode N at 169 megahertz. It's using a narrowband radio operating in 12.5 kilohertz channels. It's using fairly low data rate, between 2.4 kilobits per second and 6.4 kilobits per second. It can apply up to 500 milliwatts of output power. So all these technical features also support very long range and good penetration into buildings. When it comes to radio regulations, the 169 megahertz band is license-free in Europe. It used to be used for paging systems before cell phones and SMS took over. But there are European regulations that allows us to use this frequency band, not only for metering, but also for other types of industrial sensors, etc. You can also see a couple of references here to some white papers we have done summarizing the regulations for 169 megahertz. Okay, about radio modules. So Radiocrafts has been offering wireless Ambus modules for a long time, and we first introduced the mode N modules named RC1701HP Ambus 4. So that's a wireless Ambus modem. We also have the MPC1 variant, which is a pulse counter. It means it can be connected directly to, say, a mechanical water meter giving pulses, and the module will do the pulse counting and the radio transmissions. Then when we started to work on what should become the Wize technology, it was like a first generation known as the Ondeo Systems Protocol. So we also have modules supporting that, now referred to as the V1. And finally, we have the Wize module. So the RC1701HP Wize, that is our Wize modem, the V2. With a UART interface, you can configure the module, and you can also transmit and receive data from a Wize network. We also offer application-specific modules, and customized modules based on this Wize modem. So this would be like an autonomous module with a built-in application profile. So as an example, this could be a module that is directly interfacing a meter or a sensor, and it contains the complete application inside the radio module. That means it will support doing what is known as a ping-pong installation procedure. It will do the necessary encryption and the authentication. It can offer several interfaces for local communication that is typically used during the installation, like a UART interface or an IRDA interface or NFC interface. It can communicate with sensors or external microcontrollers using some kind of pulse interface or SPI, I2C bus, or a UART interface. Then it will allow to read and write parameters in order to configure the module, either over the local interface, which could be like an NFC interface, or it could be done remotely over the air. So over the Wize network, you could also configure parameters. And the module also allows for over-the-air firmware download. And the download is actually done by a broadcast from the Wize base station. And so all the devices in the area that is supposed to get this update is then synchronized to switch on and download the firmware at specific times when these broadcast transmissions are done. And finally, the module also contains a real-time clock to keep the timing in order to have the epoch time that is used by the Wize protocol. Okay, to help you going, we offer a develop kit. Contains 2 development boards with these Wize modules. So it got a USB interface We also provide the antennas and the cables and whatever, and also power supplies, because these are high power transmitters up to 500 milliwatts. So they put a little bit more current than the USB can supply. And there is some software tools which you can run on your PC to help you to transmit and receive the Wize packets. Okay, so that was my introduction and the first presentation today. So now I would like to hand over the microphone to Mateu.
Sure. First of all, I want to introduce myself. Working, as Peder said, in Suez, and I'm responsible for the international business in the smart metering. So I just want to give you a quick glimpse on that the Wize has worldwide right now. You can pass the next slide. Okay, so just in a quick picture, now we're talking about more than 10 million deployed, which around 60% or 6 million of them are gas meters being deployed in France. The rest, the 4 million, is a number that we are very close during this year in the smart metering for water. If we look at a closer picture of the water smart meter, we already sold. We have more than 1 million meters that are being, and we expect to grow up these contracted numbers. We are present in more than 100 cities, at least 60 in different volumes. Now we'll see. And this is just the history of the last 10 years. Also, it's important to say that we are deploying in big cities, huge urban areas, but also in rural areas in any place. And that's because, as Peder said, we benefit of two key advantages: long range on one side, which allows us with the minimal infrastructure to be almost everywhere, but also in very dense urban areas, thanks to the high penetration due to the low frequency band we're using. It proves its advantages for massive deployments. So if we go to the next slide, we will go a bit on detail. The footprint. So in Europe, it's quite easy and straightforward. It's the whole band is open. It's free, meaning there's no extra cost for using the frequency band, and it's fully supported by the European standard, as Peder had also said. Clearly, there are two countries, France and Spain, who are leading in the numbers. There are two big countries with a big positioning of Suez. So Suez has been a bit the force for these deployments and the successful deployments. On top of these two countries, we have other, not so big, but worth mention. One would be Malta, being a small country in the middle of the Mediterranean, has fully deployed 100% the whole water company, but this provides a network for any other usage in the islands. Then we have Portugal, and Portugal, I think it's worth mentioning that there's no a direct Suez business, so most of the business has been managed at the end by local partners who really believe in Wize and pushed commercially, and they have been successful. We have like 12 relevant customers with more than 50,000 meters deployed and contracts to reach to 90,000, and we see Wize being the leader in the market, as we are present in the big companies, also in the small companies, but growing and growing every year. Next one would be in Czech Republic. In Czech Republic, yes, Suez has a press helped us push the first contract in Czech Republic, mainly Brno and Ostrava. But there are other cities joining us and helping us reach the 50,000 operating meters and a backlog, a contracted of around 90,000, 80,000, sorry, 35 and 80,000. Then another country worth mentioning would be Poland. Poland is a new country where we started working last year or at the end of 2019. And during last year, even with COVID constraints, we managed to launch 5 or 6 pilots. And all of them have been proving robust and providing good performance. And now we are seeing during this year that we are closing contracts to expand and to fully deploy it in this country. So we expect a huge growth in this country on the smart metering. Also, it was a country that it's changing from walk-by solutions to fixed network, and we see that Wize is taking the big part, a big share of this market. And then there are 2 countries where we have expectations that they will start growing. One, it's the UK, which is a very specific market because it's controlled by a dozen of big water companies. And the other one is Italy. In Italy, we expect the push on the VHF solution, thanks that it's widely used on the gas sector. So we expect that once the water sector starts thinking about the smart metering, they will keep in mind the benefits proven by the gas sector. So it's another country where we have high expectations. As I said, in Europe, having it as a European standard makes it very easy to secure access to the frequency and to deploy with no regulation constraints. So if we go to the next slide, if we go to Asia Pacific, I think there's one country that it's one of a kind itself that is worth mentioning. That's Australia. In Australia, in terms of band, when we started projects, the 169 MHz band was fully available, and it's licensed by geographic zones as an application to the National Radio Frequency Regulator, ACMA. In practice, what it means, what we found is that the band was barely used, so fully available for a smart metering project, and this has been proven. And we have contracts in Queensland, in Victoria, South Australia, and New South Wales, and all of them are proving working fine, no noise because it's licensed. That's one of the benefits. And it's proving the customers that it's the perfect solution for water smart metering. You can cover rural areas, which is the case in Victoria, or more dense area like in Queensland or South Australia. I mean, we are trying to cover all aspects and prove the customers that it's a solution that fits all kind of purposes. And what's worth mentioning too is that the Wize Alliance has worked and with ACMA through different discussions and the changes, and we have demonstrated first reliability, the benefits for the community, and also the minimal impact in other users that might have devices using the same frequencies. And thanks to that, I think that ACMA has made an effort to make it much easier. So really right now, managing licenses when we are deploying in a zone, it's really something quite quick to be done. It's something which doesn't pose any problem from our perspective. And we think with ACMA there's still a place to improve the easiness to make it easier to deploy Wize solutions in Australia. And just a little, as we said, now we have 4 or 5 projects going on in Australia, and we plan to finish the year with 30,000 operating units, with a little higher volume of units sold. But we have high expectations also, because we see that we have proven the benefits and there's no regulation constraint blocking us. So we go to the next slide, my final slide. On the rest of Asia Pacific, which is the key zone where we see growth, I would say that in countries like Macau, Hong Kong, or Singapore, which are small countries where the water utility is either a national entity or a public entity or covering the whole area, we have not seen any problem when we have either Suez or the water company has gone to the regulator and tried to secure access to the 169 megahertz band. We are doing pilots there. Everything it has been proven the robustness and the value of our solution. And from the regulator, that should not be a problem to extend or make bigger scope for so proving that Wize is easy to install in such countries where there's no specific regulation on that. And then there are China and New Zealand. Again, that's different. That's big countries where we have to get a license per zone, per geographic area. And we've done it in Chongqing in China and in Auckland in New Zealand. And again, we've been able to prove that the solution works, and we've been able to convince the regulator that it was a good choice to adapt the regulation or to allow for the VHF use for these smart metering solutions. So I would say in general, in Asia Pacific and in Europe, we see quite open space of growth for Wize networks being deployed. On top of that, there's some pilots we've done in America, which has more or less the same problem, but the volumes we found are not relevant enough to put them on big numbers. So right now, what we could say as a conclusion is that we see big growth in Europe and in Asia Pacific countries. And this is everything from my side. So I will pass it to Bruno Petit.
Thank you very much, Mateu, for the and Peder for the introduction. So I'm Bruno Petit. I'm the managing director of Enless Wireless. Very pleased to attend this seminar, of course, today, and very pleased to support the Wize Alliance in the promotion of the Wize technology. I think we can move to the next slide. Okay, so as you have, I think, understood from the presentation of Mateu and Peder and from the founders of the Wize Alliance, the focus was mainly on the metering application up to now, but last year the Wize Alliance did decide that they should open the application to new applications, not only related to metering but other applications. That's the reason why we did attend to the tender, which was launched by the Wize Alliance last year, and we've been luckily awarded by the Wize Alliance for the development of a new range of 169 MHz Wize compatible transmitters, not only dedicated, of course, to metering application, but this time to building energy and efficiency and comfort applications. So we also guess that the selection and the choice for Enless Wireless was based on our experience. We have now 12 years experience in the development of low power radio sensors, multi-radio protocols dedicated to smart building applications. You would have understood from the presentation, the previous presentation, that 169 megahertz frequency band shows a lot of benefits in terms of penetrations, in terms of power consumptions, in terms of robustness and so on. So we have a long experience also in the field of developing 169 megahertz products. We have been developing these products for now 6 years, mainly on the wireless Ambus protocol. But of course, because of this experience, that was quite, I would say, easy for us to switch to the Wize protocol. So today, if we look to our deployment in France, we've we've got about 60,000 transmitters, 169 megahertz wireless Ambus deployed for different building applications, which can be metering, which can be comfort around temperature and humidity, or CO2 detection applications. Not going back to the Wize protocol because it has been done previously very, very well and very clearly, but this protocol, of course, shows a lot of benefits. It's very low power consumption, as mentioned by Peder. The applications we are targeting requires very long battery autonomy. Our customers don't want to go on site very often to change the batteries, so we have to guarantee at least 10 years battery autonomy and even more. Penetration, of course, of the 169 is very good in buildings. It's a proven technology. I think that Mateu did give you some very important figures in his previous presentation, and showing that we are not talking about pilot. We are talking about already massive deployments, about millions of units. So it's a real proven technology, and it's again very robust and secure protocol. So that's the reason why 6 years ago we decided to move from 868 megahertz application wireless Ambus to 169, showing much. I think we can move to the next one. Okay, so just to give you a very brief introduction about Enless Wireless. Enless Wireless, it's a French-based company based in Bordeaux. We are a 3 million euro company. We've got about 20 collaborators within the organization. We do also, of course, subcontract some of our activities, like production. We manufacture in France, logistic as well, and we have a strong partnership for now 10 years with a business development company, a development company in UK. We are working very closely with them for the development of our products. We have the basic certifications required today to carry on business and to do business, which is ISO. We have also some certification on the ATEX for gas applications, and of course all our products are CE certified. Today we have since the beginning of the company we shipped about nearly 200,000 transmitters are installed, mainly in France. This is our garden today. 80% of our activity, and 20% on the export market, which is really the markets we are targeting for the future development of the company. Yeah, we can move to the next one. Okay, so as mentioned before, we've been selected last year by the Wize Alliance to develop a Wize product range for smart building applications. So the situation is the following: we have launched the development of 7 new products. 3 products which will be mainly targeting the ambient applications. So they are products that can be installed in flats, offices, and which allows to measure temperature, humidity, CO2, VOC as well. And the second range of products we are developing, they are more targeting for rugged applications, still temperature, but also possibility to connect different type of sensors like 420 milliamps sensors and status sensors. All these products, because it's a long-term partnership, all these products, they will be based on the Radiocrafts RC1701 HP Wize modules. We have a very strong partnership with Radiocrafts for now about 10 years. All our products embed Radiocrafts technology, so it means that there is also very close relations between the technical team, the development team, and the Radiocrafts team. Yeah, we can move to the next page. So just to give you an update about the development planning and the availability of the products. So of course we all had to suffer from the COVID situation. So we have seen some delays in the availability of the product. But just to give you the major milestones, in July this year we should end up with prototypes. We plan to launch the pre-series in October this year, test and validation for December, and really the launch of the product in terms of production should happen beginning of next year. We are also quite cautious in terms of the COVID situation, so that's the reason why we position on this picture delivery starting in Q2 2022. So that's my part. I don't know, Peter, if you want to.
Yes, thank you, Mateu. Thank you, Bruno, for your presentations.
Okay.
So I think this takes us to the Q&A session. I can see there are some questions in the chat, and I will try to guide us through them. Let me see. So first one was, I believe, from Michael. He asked if there are any regulatory process towards allowing the use in other parts of the world, and particularly thinking about Americas. So first of all, yes, you're right. The license-free ban apply only for Europe, but you can also apply for a license in other countries. And in general, I would say this depends on the local procedures, how to do that. But as we saw in Mateu's presentation, there are installations now in quite a few countries also outside Europe. So maybe, Mateu, you can also comment on this question?
Yeah, sure, Peder. No, I would say, of course, I was showing the success we had in discussion with the regulator. I might say also that we countries where we have tried and we have not succeeded because of strong arguments. I mean, for example, in the US, which is a country we're certainly interested in, it happens that the military are using this frequency, so it was absolutely forbidden. Even that, we managed like 7 years ago to make a pilot in Iowa, but that was a temporary license, and at the end the regulators say it's they were not comfortable in allowing strong use of that frequency in the US. Other countries we might have the same problem. In others, the discussion can have a minimal technical impact. In the case of Chile, in Chile, for example, they ask us to move a bit, like I'm talking about kilohertz, the frequency, and that we did it for that case just to test it, and we made the pilot in Santiago de Chile with several, I think it's around 1,000 units. So it's possible that has any technical impact might have also, of course, an economic impact, because every time you have to make some slide into the product or any partner product developer, it's costly. But I would say yes, every country it's different story. In many we found comprehension of what we were asking and what was the impact, and we got the go. In others we didn't succeed.
Okay, thank you, Mateu. So next question comes from Edwin, and he asks, what is the netto data rate on 169 megahertz? Okay, so as I mentioned, the raw data rate over the air is between 2.4 and 6.4 kilobits per second. And this is a packet radio. So, and the radio packet contains some, say, overhead bytes. That would be the address and some control information. It would be the authentication tag, etc. And this makes up more or less 20 bytes. And I would say for a typical Wize message using metering or some sensor application would be in the order of 20 to 50 bytes. So you could say that the overhead makes up, let's say, 30% or so. And I believe this is also in relevance with the next question about the continuous transmission. So no, that is not really allowed because there are duty cycle limitations. And anyway, the Wize protocol is a radio packet oriented protocol, so it would not allow for, say, data streaming. However, if you're interested in the 169 megahertz band and the properties of that band, you can also find applications for wireless microphones and so on in some of the adjacent bands. Not the same bands as used by Wize, but in the same frequency area. You can look that up in the regulations, like the SEPT 7003 document. Then we have a question from Michael about wireless Ambus mode N and the difference from Wize. So yeah, I would say Wize is based on wireless Ambus mode N, sharing the same physical layer, and also mostly the link layer. There are some small differences in the control information and so on, but the biggest difference, I would say, is in the application layer. So that is the data you're actually transmitting, your user data. So for the specific applications, water metering and gas metering, there are defined specific application layers. We do have a bit more generic application layer specified for sensors in general. And we are actually also working on how to transmit Ambus application layer data, that is diff and WIFs, over the Wize network. Another difference, I would say, is the encryption and the authentication used in Wize. It's similar to what is specified in the Ambus standard, but not completely. So this means if you do have an Ambus, a wireless Ambus mode N modem, you could actually receive a Wize message, but the coding of the message is a bit different. So hope that answers your question. Next one comes from Barry, who is asking, are the Suez meter products 100% compliant with any Wize compliant infrastructure? I think that one should go to Mateu.
Well, yes. But I would say that the Suez doesn't make meters, or that doesn't design meters. We just put Wize Protocol as a requirement. It's the meter vendors who design, develop, and manage the transmitters. And yes, what Wize, as Peder said, Wize includes the application part of the protocol, including the data frame, the data set. So what we try is not to go out of this protocol. Why? Because it has a huge advantage. So we have one system, one network, and we can plug in the same space meters, Wize compliant meters everywhere of any brand, of any vendor. They will connect to the same network with the same protocols and authentications, and we have the same data set, so our systems and our users can benefit from the same data, never mind the meter that it's in the field.
Okay, thank you. Next question comes from Magnus, and he asks antenna size of concern. Yeah, and reminds us that a quarter wave at 169 megahertz is half a meter. So yes, very good, good question. So the antenna is actually one of the design challenges when it comes to the lower frequencies, like 169. But it is possible to make compact and usable antennas, which are not very large. So typically for a sensor or a meter, you can integrate an antenna of the size, say 5 centimeters long. This would typically be helical antennas. They will not be very efficient, but they still will give you, say, good performance. So this is a trade-off. But a typical implementation we have done with such a small antenna gave us some minus 8 dB typical in gain. So with 27 dBm output from the radio, you would still have a radiated signal of just below 20 dBm. And this is what's actually used when testing the range, and the range you have seen been quoted earlier on. So yes, it is possible, but it is a trade-off. On the other side, on the concentrator side, these are few. They are typically mounted on towers or top of buildings, and they would be then full-length antennas. So you would have very good performance antennas on the base station side. Okay, another question from Evjen. How robust is the data transmission? And what about missing data? Yes, so the robustness of the Wize technology really goes back to using narrowband radio, which means it's possible to have very good filtering. So all the out of channel noise can be filtered out. We're talking about a 12.5 kilohertz channel. We also have fairly high output power. So all that helps us to get good performance by the radio technology itself. But of course, and again, if there are, say, data collisions, a strong transmitter turns on at the same time as you are transmitting, data will be lost. But this is usually solved in the system by repeating data. So, for example, you should report sensor data at least once a day. You might set up the system to do transmissions, say 2 or 3 or 4 times a day. So then you could even miss a few of the transmissions and still get your data. You could also, for example, daily or maybe weekly, you could give like a historical record. So by using these redundant transmissions, you're also increasing reliability. Then we have a question from Axel. How are the cryptographic algorithms update handled by FOTA? I guess that's firmware update over the air. Well, it has not been planned to do any update of the encryption algorithms. Today, it's based on the AES 128, both for the encryption and the authentication. But of course, this could be done with a firmware upgrade over the air, as long as the hardware would still support it. So for example, you wanted to transfer to a 256-bit key instead. You could upgrade the firmware, but again, it would depend on your hardware also, probably. So it would be doable. Let's see, we have got one more question from David. Are there plans to share a public networks of access points or gateways to internet? I think I should also handle that over to Mateu.
Yeah. Well, I'm not aware of such a plan. Neither any idea of the major operators to do it. Not in a detail level, at gateway level. It can be discussed. Maybe we could do it at city level, or yeah, I think it's a good topic to discuss. But from what I know, there's no plan to disclose detail in internet. I mean, you must consider that in many cases it's the water company or the customer itself that the network. So it would require quite a bit of subscription, people really wishing to publish this data.
Okay, thank you, Mateu. As far as I can see, that was the last question. Okay, very good. Thank you for engaging with your questions. As last slide, I just wanted to share with you some resources. So you can look up on our website some application notes and some white papers. So those listed here should be relevant for the 169 megahertz and for Wize and even wireless Ambus. So feel free to download and have a look at those. So again, we will also share a recording of this webinar. So if you didn't get all the details, you can watch it again. So I think that was it, or let me see. In the meantime, we got one question from Ravi. You missed out in between due to power failure. What would be the link for the recording? Okay. Yes, I think the recording will be mailed out to you shortly. And if not, it will also be posted on our website together with other previous recordings of the webinars. So you should also be able to find it there if you did not get an email from us, but you should. Okay, with that, I will say thank you again to Mateu and to Bruno for joining us on this webinar, and a big thanks to all of you joining us. Thank you and have a good day.
Thank you.